How are you all? I hope everyone is fine and safe. We were doing trigonometric ratios of specific angle in the last video, right? So in this video also, we'll be continuing the leftover problems of that same exercise. Okay, before we start, always we will just catch up with revision. Okay, see, there are the 6 angles, that is sine theta, cos theta, tan theta, cot theta, secant and cosecant theta, right? So herein we have the specific angles. That specific angles are 0 degrees, 30 degrees, 45 degrees, 60 degrees and 90 degrees. So we need to remember this table. The easiest way to remember the table is remember the sign values and other things you need to play around. Okay, so how to actually make up the sign values? It's like we are writing this 0, 1, 2, 3 and 4. Okay, and next we are dividing the whole things by 4 everywhere. Okay, then we are taking out the square root of it. So square root of 0 by 4 is 0, square root of 1 by 4 is 1 by 2, square root of 2 by 4 is nothing but 1 by root 2, square root of 3 by 4 is nothing but root 3 by 2, and square root of 4 by 4 is 1. Okay, once we get these values, for the cos value we just need to swap the values. Okay, it's like that. Cos 0 degrees is 1. Okay, here it is sine 90 is 1, right? Here cos 0 is 1. Okay, then this way, that root 3 by 2 comes under cos 30, and here it is cos 60, it is root 3 by 2. Under 45 degrees we get the same values, 1 by root 2, it coincides. Herein it gets swapped. Okay, it's this way, it goes this way. Okay, so we just got this sine value and we are just swapping and getting the cos values. Once we get these values, we know what is tan. Tan is nothing but sine divided by cos. So what is sine divided by cos? These two values we need to make up to get the value of tan. So 0 by 1 is 0, 1 by 2 divided by root 3 by 2, it's nothing but 2 cancel, 1 by root 3, 1 by root 2 divided by 1 by root 2, root 2 gets cancelled, it is 1. Root 3 by 2 divided by 1 by 2, 2 and 2 gets cancelled, we are getting root 3, and 1 divided by 0 is infinity, it is not defined. Anything divided by 0, any number division by 0, it will be infinity. Okay, the cot is nothing but the reversal of tan. So we will be taking this way. Okay, this infinity, root 3, 1, 1 by root 3 and 0. That we are swapping the cot value. The same thing goes with the secant. Once you get the secant value, you will get the cosecant value. But what is secant? We have learned in the previous formulas, that is secant is nothing but 1 divided by cos. So we are dividing dividing this, we are getting the value of secant by division by the cos. Okay, so 1 divided by cos is nothing but cos, reversal of the cos is secant. So 1 divided by 1 is 1. Root 3 divided by 2, reversed order of it is 2 root 3, 2 by root 3. 1 divided by root 2, reversal of it is root 2 by 1. 1 by 2, reversal of it is 2. And 1 by 0 is nothing but the infinity. Okay, 1 divided by 0 is infinity. Now what is cosecant? Simple. We need to swap up. It is infinity, 2, root 2 common, root 2 by root 3 and 1. This is the easiest way to remember this table. Okay, in exam always be ready with this table in a rough column or a page which is at the end, so that it will be very easy when you get the problems in that kind. Surely you will get the problem page on this table. So it will be better, yeah, you just roughly write the table back side of the paper with a pencil, and you can quickly move on to the problems. As and when you get the answer sheet, you can start writing drawing this table. Okay, now we'll move on to the next problem. We have already done the 4th problem from that exercise. We'll be doing 5th problem in this video. 5th, 6th and 7th problem will be completing the exercise in this video. Let's start exercise 11.2, 5th problem. Let's continue with it. In right angle triangle PQR, right angle is at Q. So there a right angle triangle, that is PQR, where at Q it is 90 degrees. Okay, and PQ is 6 centimeters. P and Q is given as 6 centimeters. Okay, angle RPQ is 60 degrees. It means that whichever thing is there in the middle, that is P, angle P, okay, it's given as 60 degrees. This angle is given as 60 degrees, okay. Determine the length of QR and PR. We need to find QR and we need to find PR. See, in previous problems, what was given, we were given with two sides. We need to get another side, and also this, we need to find out the angles, okay, using the trigonometric ratios. But in this problem, there's an angle already given, that it is a 60 degrees, okay, from the P, angle P. Okay, we need we are given with one of the length of PQ, that is 6 centimeters. We need to find out other two lines, okay, other two lengths, that is QR and PR. So in this kind of problem, what we'll do, first thing what we are going to write is the given aspect. What is given? It's a right angle triangle. Angle Q is 90 degrees. Right angle at Q, it's given. That means angle Q is 90 degrees. Okay, angle RPQ, that is nothing but angle P is 60 degrees, right? Whatever there in the middle, that angle's value will be given. Okay, and PQ is nothing but 6 centimeters. We need to find the length. What we will do? See, what from angle PP, what is given? The adjacent of angle P is given. Okay, the opposite of angle P is not given, and hypotenuse is also not given. So, well, in that case, just check out for some trigonometric ratio which deals with adjacent. Okay, sine, does it deal with adjacent? No, it is opposite by hypotenuse, right? Cos, does it deal with adjacent? Yes, adjacent by hypotenuse. And tan, does it deal with this thing adjacent? Yes, opposite by adjacent. Okay, it's our choice whether to take, because adjacent value is already given as 6 centimeters. We have to consider the value ratio from these two things. Okay, basically. So either we'll take cos and find out the value, or we'll take tan and find out the value. It is one and the same. But you know, for our ease, we will take up tan. Okay, let's take up the tan. What is tan theta? What is the formula for the tan theta? It is opposite by opposite by adjacent, right? So in our case, what is tan theta? What is theta? Theta is already given as 60 degrees. Okay, and what is opposite? Opposite is unknown still. It is QR. Okay, what is adjacent? This is PQ. So QR is still unknown, but what is PQ? PQ we know is 6. Okay, so what are we going to do? What is tan 60? Tan and 60. What did we know about tan 60? It is root 3. Okay, so let us write in place of tan 60, it is root 3, which is equals to QR by 6, which implies QR, keeping QR, sending the 6 to the other side, we are getting QR value as 6 root 3. 6 into root 3, 6 root 3. We can't simplify further. Okay. Okay, this one we have got the value of QR, right? We just got one of the value. Now we are left with PR. Either you can use any of the formula to get it, because we already have got another side. Okay. So which side did we get it? 6 root 3. We have found out this opposite side. Or you can do one thing. You can directly use the theorem using Pythagoras theorem. Okay, herein we got the value of opposite, that is 6 root 3. Okay, and we got adjacent. What is missing? The hypotenuse. The basically, you know, anything and everything which we were doing till now is using the Pythagoras theorem. But also you have an option that you can even use any of the formula to get the answer. Okay, but in our case, you know, it's better, like it's easy for us that it will be getting in a mind that we can use the Pythagoras theorem. Okay, by using the Pythagoras theorem, we know that PR square is equals to QR square plus PQ square, right? We have this formula. I mean, according to the Pythagoras theorem, this is the thing. Okay, what is PR? We don't know PR square. Okay, what is QR square? We just got to know that. What is QR square? QR is 6 root 3 the whole square. Plus what is PQ square? PQ we already know it's 6 centimeters. Okay, so PR square is nothing but 6 into 6, 36. Root 3 into root 3, it is 3. Okay, 6 6 are 36, right? 6. Now PR square, we are just simplifying the formula. I mean simplifying the multiplication. 36 into 3 is 108 plus 36, which is equal to 144. What is PR? 144, root of 144, which is equals to 12 centimeters, right? So we got our hypotenuse value as 12 centimeters. What we need to find out is PR. We already got PR. So this is the answer. This was the easiest one, right? Okay, let's move on to the sixth problem. In triangle XYZ, right angle is at Y, YX is nothing but X, XZ is nothing but 2X. Then determine angle YXZ and angle YZX. Okay, in this problem, don't get scared seeing the problem like you have so many X's here. So like it's simply, instead of giving some centimeters or something, it is given in value in the terms of X. So whenever you see such problems, first try the given aspects. Okay, the given is what? Yx is x, small x, the term, and xz is the 2x. Okay, now since it's a right angle triangle, we are just drawing the right angle triangle simply. This is the routine for every problem, right? At 90 degrees, I mean the right angle is at y, so x, y and z. Okay, you can take either ways. You can take z, xy or xyz. Okay, so what now seeing this figure, we need to put up the given values. What is yx or xy? What is small x? It's given. Okay, what is xz? It's nothing but xz is given as 2x. Okay, these two values are given. This is unknown value now. So when two lengths are given, we need to find out another value, another length. What we use a Pythagoras theorem. It's a basic thing. Okay, but let's first complete the question. Determine angle yxz. Nothing but angle yxz we need to find out. Whenever the thing is given in these three terms, we always take the middle angle. Okay, we need to find out angle x. It means that angle y, z, x, it's nothing but angle z. We need to find out these values. Okay, so this angle we need to find out, this angle we need to find out. Let's not take it at these values as x and get confused. Okay, let's proceed further by using Pythagoras theorem. Okay, by using Pythagoras theorem, we know that zx square, which is equal to xy square plus zy square, right? Zy square. It's simple. See, it's xz square is equals to xy square plus yz square. Okay, this is the basic Pythagoras theorem we are applying because we have we have both the sides. We can find out the third side very easily. Okay, so xz square, we do we have zx square? Yes, we do have 2x. Okay, because xz is only 2x and the square we are copying as the square. We have xy square, yes we do have, that is x square, x, and the square ka we are copying square. Okay, plus do we have yz? No, we don't have yz, so we'll keep yz square as it is. Now what is that? 2 into 2 to the power 2 is nothing but 22, that is 4x square, which is equals to x square plus zy square. Now we need to find out this term. Okay, zy square, we know the value, other values, right? So what we are doing, keeping zy square here and sending x square the other side, all the x terms at one side, zy square keeping here, 4x square is already here and we are sending this value there. That means that it is minus x square, right? Plus x square gets that side of the equation, goes to that side of the equation and gets minus x square, right? So zy is nothing but a root of, see, it's nothing but 4x square minus 1x square. 4 minus 1 is 3x square. Okay, so herein what we can infer, zy is equals to, anyhow root 3 will be root 3. But x square and root gets cancelled, right? So it is root 3 into x. On x there's no root because we have already taken out the root and the square and we have just cancelled that. Okay, we get root 3 into x. Okay, so this is the value of yz, root 3 into x. Okay, now since we need to find out the angles, we will be using our table. Okay, I mean we will be using our ratios. The best ratio, with the easiest ratio when we usually use is of tan. Okay, so tan, let us take this angle as capital X. Okay, anyhow, it's tan x is equals to, what is tan? What is tan? Tan is nothing but opposite by adjacent, right? What is opposite for x? What is opposite for x? It is nothing but zy. What is the adjacent for x? It is xy, right? So herein, do we have zy value? Yes, we did got the zy value. Root 3 into x. What is xy value? We got x. X and x get cancelled. So tan x is nothing but root 3. What is in our table? Where do we get a root 3? Where do we get a root 3 in tan? Where do we get the root 3? At 60 degrees. So we are taking tan 60 degrees is equals to root 3, which implies angle x, we are taking this angle, right? Angle x is nothing but 60 degrees. Okay, we got 60 degrees, which is in indirectly, which is equal to which we are asked in our question, angle yxz. Okay, in the to just for the proper presentation, because it is asking in terms of x angle yxz, we are writing this way. Otherwise, even if we leave at this point, it is fine, but you need to complete it. Next thing is that the same tan will be applying to z from a point of view of z. Okay, we just got tan x from point of view of x. Now the same thing apply for z, tan z, opposite divided by adjacent. But from this point of view, what is opposite side? This is its opposite side. X, y is the opposite side. Okay, but from point of view of angle z, what is the adjacent side? It's not this, it's this. Okay, yz. So what is xz? What is xy? It is x. What is yz? It is divided by root 3 into x. X gets cancelled. So tan z is nothing but 1 by root 3. Okay, at 1 by root 3 in the tan table. Okay, in the tan table, where is 1 by root 3? At which angle it is saying? It is 30 degrees. So answer is tan 30 degrees. We are having 1 by root 3. So our angle z is nothing but 30 degrees, right? This 30 degrees. And since in the question it is given in this term, angle y, z, x, we will be writing in the same way. Angle y, z, x, we got the answer. Okay. So this problem was the easiest one. It's just that it did not give the whole directly the numbers. It just gave the the answer in form of x. In terms of x. It was very simple. You don't get confused in examination. It's the simplest way to be done. Now let's move on to the 7th problem. Okay, is it right to say that sine A plus B is equals to sine A plus sine B? Justify your answer. In this problem, we need to show whether it's equal or not. Okay, so what we will be doing, like since A and B, we just can't solve, we can't go ahead in this, right? So what are we assuming? Let A be 30 degrees and B be 60 degrees. Remember, whenever there's a problem, pertaining to this showing some of the identity, okay, you need to assume some of the figures, okay, which we have already learned the specific angle figure. So we are taking the specific angle, but remember, whatever you take A and B, that should, this should totally be equal to 90 degrees, right? 30 plus 60, it should be 90 degrees. See, in exam, you don't need to remember that you need to take A as 30 and B as 60 always. Okay, for the assumption purpose, I'm not asking you whenever this problem come, you need to mug up the thing and go. So always remember that whatever values you are taking it here, you can take any of the value, but take in such way that the sum of it ends up as 90 degrees. We will be learning why and all in the next part of the video. There's a clear explanation regarding that. Okay, for now, you just remember that total should be 90 degrees. You can even take A as 45 degrees, B as 45 degrees also. Okay, and try your answer. I'm taking A as 30 degrees and B as 60 degrees. Let's proceed further. Whenever there's a problem of justify the answer or show that or prove that, you need to take LHS and RHS. Start with LHS and end with RHS, right? So let us take LHS, which is what? Sine A plus B, which is nothing but, what did we take as A? A is 30 degrees, right? What is B? B as 60 degrees, right? So sine 30 plus 60 is 90 degrees. What is sine 90? From our table, get back to our table. Sine 90 is 1. So we are getting answer as 1. Okay. Now let us take RHS. Okay. Now let us take RHS. It is nothing but sine A plus sine B. Okay. Sine A, sine 30 instead of A, plus sine 60 instead of B, right? So now what is sine 30? Again back to the table. Sine 30 is 1 by 2. Sine 60 is root 3 by 2 plus root 3 by 2. Herein if you take out the LCM, it is 2. Okay, 1 plus root 3. This is the answer. You can't, even if you solve this till the end, your answer will be less than 1, right? So in this case, you see its LHS is not equal to RHS, right? So we conclude sine A plus B is not equal to sine A plus sine B. Okay. See, I really want you people to do this problem using A and B value differently. Obviously, we have to use all the specific angle values only, because we can easily get these values. Otherwise, we don't get the value very quickly. Okay, use this table. I mean, the values 0 to 90 degrees. I mean, between that value as A and B, and solve your problem. This holds good for everything. Okay, so that was it for the day. And we'll surely post videos daily, and we'll be completing all the trigonometry, each and every problem. Don't you worry, and stay in touch. Do like my channel, subscribe it, and share it. Don't forget to press the bell icon. Take care, guys. Bye bye. Have a nice day.